Hello, friends. I hope you all are doing good. So, in this lecture, I'll be discussing the second question of my data science end semester paper. So, in second question, we have asked what is data imputation and how would you decide on the best imputation method for handling missing values in a large data set? Discuss the potential risk of using the mean value method and explain how the nearest neighbor imputation method works. So let's begin. First, we'll see what is data imputation. In simple terms, data imputation is a process of filling in missing values in a dataset. Missing dataset is a common issue, and how we handle it can have a big impact on the quality and accuracy of our models. Imputation allow us to deal with these gaps without losing valuable data. So basically, we have the data, and it's not every time true that we got the complete data. Sometimes the data sometimes the data might leak some values which we have to fill. So data imputation is that method by which we can fill the missing values. There are several methods for imputing missing data, and choosing the right one depends on the types of data, the nature of the missing values, and the context of the problem. Now, let's see some of the most common methods of data imputation. The first is mean imputation, where we fill the missing values by taking the mean of the remaining values. The second is median. We replace the missing value with the most centered value of that particular column. And the third is mode imputation, in which we fill the value with the most occurring value in the particular column. And the another method is nearest neighbor imputation, where we fill the missing values based on the nearest data point, like the adjacent value of that missing column can be filled by using the nearest neighbor method. And the another thing we can do is we can simply drop that all records of the missing data so that we can perform our operations. And the another method is make a reasonable guess based on the knowledge of the underlying domain. And the another method is random value. Basically, you have to write any random value which you have in mind to fill that missing gap. Now, let's talk about how to decide on the best imputation methods for our data set. For large data set, there are few things to consider before you choose an imputation strategy. So, the first one is the type of data. So we have to see we are working with numerical or categorical data. For categorical data, you might use the mode, whereas for numerical data, we need the mean and the mode, or other statistical methods could be more suitable. And the second one is pattern of missingness. Is the data missing at random, or is there some underlying pattern? If data is missing randomly, simpler methods like the mean or the median might work. But if there's a pattern, more sophisticated methods may be required. And the third one is impact on analysis. Will imputing the missing value significantly change your model results? If yes, a more complex methods like nearest neighbor or regression imputation might be appropriate. So basically, by finding the missing values using imputation, if our significant model get changed, we have to use a more complex method like nearest neighbor or regression imputation. Now, we'll talk about the potential risk of using mean imputation method. While mean is a simple and fast technique, it has some important downsides. When we replace missing values with mean, we risk distorting the data distribution. For example, if we have the outliers in the data, they can pull the mean in one direction, and replacing missing values that with that mean may skew the result. It can also reduce the variability in the data, making your model less sensitive to real trends. So basically, by using the mean value, if we have outliers in the data, suppose we have a data of 10 employees having salary as, in which the 8 employees has salary under 1 lakh, and the 2 employees have salary around more than 10 lakh. So basically, that the employee of the two salaries is the data outlier, which will basically shift the mean their side, which will ultimately give us the wrong missing value. Now we'll see how does the nearest neighbor imputation method work. Nearest neighbor imputation is a more advanced technique that fills in missing values based on the values of the closest data points. It is often used you want to preserve the relationships in the data and avoid biases introduced by simpler methods like the mean. How data imputation, how nearest neighbor works. First, we'll need to identify a data point with a missing value. Then we'll find the most similar data points, or basically the nearest neighbor based on some distance metric like Euclidean distance. So basically first we have to figure out which data point is missing, and from that data point what are the nearest values. And we can find out the nearest neighbor by using the Euclidean distance, which is basically the distance formula that we have studied in our school. The missing value is then imputed with a value based on these neighbors, either by averaging their values or using other methods like weighted averages. So basically, the we can get more than one neighbors. So basically, at after getting the values, we can basically take the average of those values to get the missing values, or basically we'll take the weighted average, which means the more how many neighbors are pointing towards the same value. The advantage of nearest neighbor imputation is that it helps preserve the underlying structure of the data, which is something methods like mean imputation can't do. So it will basically preserve the structure of the data, and the mean method while can change the pattern of the data. However, it can be computationally expensive, especially for large data sets, since we need to find out and evaluate the nearest neighbor for each missing value. The nearest neighbor is basically time consuming, but it gives us more accurate missing value, while mean methods can point some errors if we have outliers in the data. Okay, guys, so this is all from the video. I hope you liked the video. Thanks for watching. Bye.